We are going to look at solving some exponential equations. The first one that we're going to look at is one of our best case scenarios for exponential equations. If possible, we want to make our bases on each side the same. So we can rewrite 25 as something that is base 5. So our left-hand side will remain 5 to the 2x plus 1, and my right-hand side becomes 5 squared because 25 is 5 squared. Now that my bases are the same, I can ignore them and deal only with the resulting equation. So 2x plus 1 equals 2, just equating the exponents. If the bases are equal, then the exponents must be equal. So 2x is 1, x is 1/2. In the example here on the right, we have a 27 and a 9. Now we can't write 27 as base 9, but we can write both 27 and 9 as base 3. So the first step in doing that is 27 is 3 cubed to the 4x, and 9 is 3 squared to the x plus 1. And then if you'll remember back to your exponent rules, when you raise a power to a power, you multiply the exponents. So we can rewrite this again as 3 to the 3 times 4x power. And this side can be written as 3 to the 2 times x plus 1 power. So now we have the same situation that we had in the previous problem where our bases are equal, so we can ignore them and deal only with the exponent, because if the bases are equal, then the exponents are equal. So 3 times 4x equals 2 times x plus 1. So 12x is 2x plus 2. So subtracting 2x from both sides, 10x is 2. So x is 2/10 or 1/5. Well, now let's look at something that's a little more tricky. If I have 4 to the x minus 1 equals 3 to the 2x. So when we look at these bases, we know immediately that we cannot equate our bases. We cannot write both 4 and 3 as something to a power, with that something, the base, being the same for both sides. So what we're going to do is take the log of both sides. It doesn't really matter whether you take the log, the common log, or the natural log, although we usually don't use natural log unless we have an e in the problem. So we're going to go ahead and use the common log. So I'm going to have log of 4 to the x minus 1 equals the log of 3 to the 2x. Now I'm going to use my properties of logarithms, and remember we take an exponent and move it out front. That's one of our logarithm properties. So this will become x minus 1 times log 4, be sure to use parentheses, equals 2x log 3. And then what we need to do is we'll need to distribute this log 4 to both the -1 and the x. So x log 4 minus log 4 equals 2x log 3. Now remember, what we're trying to do is solve for x, so we need to get all of our x's on the same side of the equation. So I'm going to move my negative log 4 to the right, and I'm going to move the 2x log 3 to the left. So I have x log 4 minus 2x log 3 equals log 4. Now, very often students can get to this point, but then they're not certain what to do. Well, notice on the left-hand side that we have a common factor of x in each of those terms. So we can factor that x out. So I would have x times log 4 minus 2 log 3 equals log 4. And then to solve for x, we'll divide both sides by this expression. So x equals log 4 divided by log 4 minus 2 log 3. So that would be the exact answer. If you were looking for a decimal equivalent or they told you to round to 4 decimal places, we do have to be careful when we put it into our calculator because we're going to need a lot of parentheses. Remember, when you type in the word log, your calculator automatically opens a parenthesis. So we'll have to close it in each of those situations. And then you also want to be sure that you have a parenthesis around your entire denominator. You can put one in the numerator if you like, but since it's just a monomial, it doesn't have any addition or subtraction up there, you can leave it too. So let's type that in and see what we get so you can practice that yourself. So let's see, log 4 divided by log 4 minus 2 log 3. Negative 1.7095. Okay. Let's do one more like that. We are going to look at 6 to the x plus 1 equals 4 to the 2x minus 1. So again, we have the problem that we cannot write 6 and 4 as the same basis, so we will take the log of both sides. So I'm going to have the log of 6 to the x plus 1 equals the log of 4 to the 2x minus 1. Now, using our properties of logs, we're going to take the exponent and move it out front. So now we have x plus 1 log 6 equals 2x minus 1 log 4. This time we're going to have to distribute on both sides. In the previous problem, we only had a single term here, so we didn't have to distribute. But here, since we have two terms, we're going to have to distribute. So we'll have to distribute the log 4 on the right and the log 6 on the left. So we'll have x log 6 plus log 6 equals 2x log 4 minus log 4. Now what we need to do is get all of our x's on one side and everything else on the other. So I'm going to move the log 6 to the right and the 2x log 4 to the left. So I'll have x log 6 minus 2x log 4 equals negative log 4 minus log 6. Now we're to the point where we have a common factor of x in both terms on the left, so we'll factor it out. X times log 6 minus 2 log 4 equals negative log 4 minus log 6. Then to solve for x, we're dividing by this expression here, both sides. So x is negative log 4 minus log 6 over log 6 minus 2 log 4. Now, when we put this in our calculator, we're going to need a lot of parentheses. Again, every time you type in the word log, your calculator opens a parenthesis, and you'll need to be sure that you close it every single time. Actually, let me go back and put those in a different color. There we go, so you can see them a little bit better. We also, since we have an expression in the numerator, we need parentheses around that whole thing, and we need parentheses around the whole denominator. So let's type that in here. Let me shove things over. Let's type that in and see what we get. So we have negative log 4 minus log 6 divided by log 6 minus 2 log 4. 3.2402 would be the rounded to 4 decimal places answer. I hope this gives you some clarity on exponential equations.